Welcome to all of you. So happy that you all have joined us today. And we're here today with Justine Alexander, who is a senior conservation scientist with the Snow Leopard Trust and our beloved executive director of the Snow Leopard Network. So we're very happy to have Justine do this session for us. It's a privilege because she doesn't usually get much time. So I'm sure you guys are going to gain a lot out of this session. Over to you, Justine.
Thank you, Reki, and thanks for everything you're doing for our SLN Summer Exchange and bringing this all together. So we're really going to apply QGIS to snow leopards, and when we plan snow leopard surveys or other ways we can apply our work. So before we start, as people come in, I want to ask you guys a few questions. First of all, can you go to the chat? In the chat, you'll see a link that should be coming up that Reki is going to share. Can you go to that link and just so we get to know each other, because I hope that this session is interactive and we also learn from each other. I hope it's not just me sharing, because I'm not a GIS expert in any way. I've just been using GIS for the last 15 years and applying it in my work, and I'm going to be sharing some of those practices. So I hope that some of you today can also be sharing how you apply it, and what are things you're hoping to use it, perhaps if you don't really apply it yet. So we're already getting some people saying where they're coming from. So you can go to the link that's in the chat and then say where you're coming from, and we'll see on our map where this team today. Oh, we have a lot from it seems India, Pakistan area already. Is there any other countries? Oh, we see, I think, is that Myanmar, Mongolia? Ooh, we also have West Africa. Very nice. Uganda, I think. Fantastic. Oh, the bubbles are coming in, a really nice range. Let's give everyone a few more seconds. If you haven't also put your name in the chat and who you are, please feel free to do so. Great. Anyone else want to add where they're coming from? Please do. Okay, so that's great. That's a good idea to get an idea of where we're working on, because for GIS, it's also, it matters where you are in terms of what tools you use for that location to get accurate estimates and make accurate maps. So it's a really good idea to have a look at these maps. Okay, so I want to first also get an idea on what you hope to learn today. So if you can stay on that link that you originally put where you're from, can you write in a little blurb on what you expect? Because I'm sure that many of you have a range of different experiences with QGIS and or maybe no experience. So it's a really good opportunity to say, bluntly, I have no idea. I've never even opened or downloaded QGIS, and that's fine. Just put it in the chat. Or perhaps you have a lot of experience and you just want to tweak your skills a little bit or see how someone else shares their QGIS knowledge. So how to use the QGIS for mapping and conservation planning, a clear understanding of QGIS, mapping and analysis. Nice. Anyone else? Please do feel free to go to the chat and put in that. Put in the answers. We'll put in, I think we have to put in the link again one more time for those that arrived late. Mapping spatial distribution of species. Okay, so seems like a few of you want it for real analytical skills. And Sagnik is saying that they've used it to make a few maps using ArcGIS, but never QGIS. Okay, that's interesting. It's always nice to compare. They're different, but they have many similarities. learn mapping and others' experiences working with it. Yes, we'll definitely do that today. Mapping, analysis of habitat stability and connectivity. And I just want to apply it for mapping, spatial analysis, and modeling, and so on. Okay, so as many of you said, there's many different ways we can use QGIS. So today we won't have time to look at everything, but hopefully we can address some of these hopes that you want to look at today. So next, now is a question, what can we do with GIS? So not only QGIS, but generally GIS. And remember the quote by Tobler's law that says everything is related by location. So what is the strength of GIS? And I would like to encourage you to be more specific. So instead of just saying spatial analysis, can you give an example? What kind of spatial analysis can you do or have you done using GIS? If you say like create a map, can you share what type of map you've created? Was it an elevation map? Was it a species distribution map? Please feel free to be more specific and go in the chat. And again, it's actually through the link I sent. It should be the next question that's asked. Go ahead and answer that question. Okay, spatial species distributions, habitat ranges. Okay, design grid surveys. So maybe you want to create a grid on your map to then sample where you want to go and collect data, or you want to extract spatial covariates for those grids. Very nice. So you can create an average for that grid area for your analysis and make raster prediction maps. So you maybe more prediction maps of where snow leopards or other species are. How to use lay grids and survey. Okay, nice. When you plan a survey, you might want to put your transects and then plan accordingly. Species distribution modeling. Yes, it can help with the analysis with combining with some other analytical tools such as R. It could be very powerful. And to extract environmental anthropogenic data using covariates for occupancy analysis. Very nice. Okay, yeah, so you can create maps and then extract averages again for certain grids. And again, another one's very similar. So habitat suitability and data extraction. Nice. Any other ways we can use it? I think everyone here seems to have similar experience. It's very much related to extracting covariate data or related to species distribution. Any other ways we can use GIS for, and maybe think about in the snow leopard, about your snow leopard work. It doesn't only need to be ecological work, it could also be with social surveys. How have you used GIS or could use GIS? I can start giving you some ideas. So we can, no one has mentioned, but we can plan our camera trap survey. So it can be a planning tool, not only analysis tool. We can plan using map our camera traps and look where they are to ensure that they sample the appropriate covariates before going out. We might be able to use the map to navigate. I think maybe this is because we're part of the new world and we use our digital maps on our phones. So we don't always use and make maps before going out. But I know that many teams work in areas without phone connection. So we make maps and you might want to laminate it and then bring it to the field with you. That can be really helpful beforehand. You can also measure distances with GIS. Or calculate areas. For example, a simple question could be, how big is this protected area? And then you could measure that with QGIS or GIS. You can look at overlap between different features and see how much of an area overlaps with another. So please, if you have other ideas, please continue writing it in the chat. More about predictive, okay, with topographic and climatic layers. And where you're going to sample for upcoming surveys. Nice. And yeah, so there's many ways we can use it. and not only for ecology, also for social surveys. You can map where are your communities, where are they located, and what are some special features, some attributes related to those communities, and map it accordingly. You can look at the range size, maybe the habitat range of a snow leopard, the home range of a snow leopard, and how it moves using its collaring data, for example. So as you noticed, everything is related to location. Everything you can do with it is related, okay, where is the animal, where is that feature located on a map? And which is a very powerful tool. Conflict zone mapping, someone's writing in the chat. Community resource mapping, very nice, yeah. So I want us to expand our brain further than just ecology, and also think about the social science questions we might have. Okay, so today, what are we going to do? So I heard from you guys on what you expect. Well, unfortunately, we don't have that long. We have around an hour and a half or an hour to look at all this, so it's time limited. So based on that, we'll really try and share some general concepts related to QGIS, and then we're going to apply it on two aspects of the snow leopard, using snow leopard data, one at the snow leopard range level, and then also at a camera trap survey level, looking at mapping. And then we're going to discuss different resources where you can get information related to QGIS, because often, you know, many of us spend a lot of time online looking for these free resources, and it's great to share and know where we can find resources for different layers or different data types that are available. So this isn't a good example of a map, really showing the snow leopard range. It was developed by the third pole. And one really nice thing is it shows all the different elements that you might want to have in a map. For example, it has the different labels related to the different features. It has the scale mark, and it has another map that shows where the area is within the Earth is plane. Yeah, and also a northern, where is the northern hemisphere moving towards? So it's important to think about when you create maps that you want to get published. Here's another map related to someone who published, I think she's part of the Snow Leopard Network, related to camera trap layout in northern India. And you can see that in each of her locations, she provided different attributes, you know, where the cameras were located, but also where the animals were captured, whether it was musk deer or baral. And she created spatial relationships related to them. So what is QGIS? What do we think about when we look at the basics of GIS? What is it doing? It's actually, you can see it almost like a layer model. It's putting together different information related to the real world. And each layer is perhaps a different thematic related to the map. So, and this is one of the oldest and most common techniques for creating maps, because you don't want to overload the reader by trying to represent perhaps the real world. You might want to focus on a different theme you're focusing on. Maybe it's land use, elevation, where streets are, where people are. And these data sets also come in different formats, some in vector files and others in rasters. And we're going to talk about that later. So some can be using the same coordinate reference system, while others might use different coordinate reference systems. And that's also important to keep an eye out, because the way it's projected onto a map might be different. So some of these files you might be able to go and collect yourself in the field. For example, you have a GPS and you're going to note down where your camera traps are located, while other sources of data you can find online. For example, if you want to do a spatial analysis, you can get a really nice overlay of elevation for your study area, or maybe forest cover. So it's important to see these as different layers that we bring together to create our GIS map. And there are two types of layers, generally speaking, that we are working with, and we generally work with when we're creating maps. There are more layers now, and as GIS develops, it gets even more powerful. But when you think about it in the beginning, I think it's helpful to think of it in these two branches. So there's vectors, which are mostly shapes. And then there's rasters, which are mostly seeing those shapes in grid forms. So as you can see here, both of these types of data can represent the same things in just a different way, but they both don't represent the real world exactly, but they try to do it in different ways. One with shapes and the other is through a grid format. So we're going to look at each of these in more detail. Vector data. So what is vector data? Vectors data can be either points, lines, or polygons, and they're associated with different XY coordinates related to GIS. For example, points are zero-dimensional objects that contain a single coordinate pair, an X and Y. And they're usually used to create discrete features. For example, your camera trap. Where is your camera trap? Where is your village? This is important when these discrete features are mapped. Lines are more like long, and they're one-dimensional features, and they're used to represent linear features like roads, streams, boundaries, for example. And they normally have an associated attribute related to length. And finally, there's polygons that are two-dimensional features, and they're created by multiple lines that loop back and create a kind of closed features. And in case of a polygon, the first coordinate, the point on the first line of a segment, is the same as the last coordinate pair on the last line of the segment, which represents that loop. And this could be city boundaries, lakes, vegetation communities, a nature reserve. You can have a variety of different polygons. And polygons generally have areas. You can have an attribute related to areas. Okay, so this is a recent, if you go to the QGIS website and look at their tutorials, you'll see this, and it nicely represents the three different types of vectors, the points, the lines, and the polygons, and how they're created. And I just wanted to show this because I wanted to bring your attention to the attributes part, where it says point attribute, polyline attribute, and polygon attribute. As you can see, each of these are not just a point or a line or polygon. They have a lot of information related to that point. For example, this X in blue could have information related to what type of tree, or what color it is, the size, and so on. The line could have information on its length, what the name of the line is, and so on. So each of these attributes basically describe the features, and there can be countless different attributes for each feature. And that's the real powerful thing about QGIS, because it's not just showing a point on a map, it has loads of information related to that point on that map. And you can use that information in different analyses tools later, or just for mapping itself. So that's a vector. The second major data form is called a raster data. And it consists of rows and columns that are equally sized pixels, interconnected by a planar surface. So I want you to take a moment, I'm just going to skip to the next slide, and take your favorite snow leopard picture. So perhaps it's this picture on the screen. And when you look at a snow leopard picture, it really depends on the resolution of that picture. And if you have a really good picture, it's high resolution, you have very tiny grids within that picture. That's what composes that picture. But if you have a very low resolution picture, it's often much larger grids that are composing it. And that's why it creates this blurry effect. So that's exactly the same with rasters. They're created by grids, and the resolution really determines the amount of data that's found in that raster. So just going to go back now to that raster sheet. And as you can see, this is in a more zoomed in view of what a raster could look like. And each of these boxes have information related to it. Perhaps the information is elevation, or perhaps it's forest cover or percentage of snow leopard being distributed in that area, the probability of finding a snow leopard there. And depending on the resolution, it might be displayed like this on your GIS window. And you can see this is a higher resolution, and each grid is these tiny pixels are composed of each grid. So each raster measures a different variable. This is something to remember, which is very different from the vectors, right? The vectors, you could add many different variables to that. Here, generally, each raster has measuring a different variable continuously throughout the file. And they're normally saved as JPEGs, BMPs, and TIFF file formats. But there's a range of other formats that could be used, but these are generally the favorite ones. And one thing to remember about rasters, again, is the resolution of your raster, because that will affect the analysis that you take forward. Fine pixeled resolutions might also take more time in your analysis and more space in your computer. So that's something else to remember. So the type of raster you use affects analysis, but it also affects the time analysis or the requirement space or processing time for each analysis. So again, your favorite picture. Great. So those are the two main types of data. And for those that are familiar with the GIS, thanks for staying with us. But I would now want to ask you guys a question. Can you give examples of a vector shape? So this time in the chat, if you can go to the chat and, I'm just gonna, can you go to the chat and give some examples of what vectors you are familiar with? Okay, grid files for camera trapping. Great, so the camera trap locations. So we're focusing on vectors or shape. So like here, perhaps the points of where your camera traps are located. Alice says roads, where her roads of perhaps where people are using. We also have, national park boundaries that might be more like polygons, roads or streams like lines. Grids of urban mapping and points of camera traps. Polygon might be where the urban areas are, and camera traps are the points. And the points can also be collaring data too, right? Movement paths of individuals. Ranger post locations. Nice, Joshua. Super. Okay, now can you provide other examples of rasters for grids? What are examples of different raster files that you are familiar with or you commonly use in your work? And the first one, layers of bioclimatic variables. Great, Sanjini. Yeah, and we can maybe get also different predictions of those layers in the future, the climatic variables. DEM, so can someone, I see DEM written in the chat, can someone explain what that is for others that are less familiar? Okay, and I see Mustafa already has elevation layer, nice. Detection probability of tigers on a grid cell. Nice, so you can represent it more as a grid. Elevation maps, habitat type. Yes, it could be different habitat types. Digital elevation models. Great, any others? I know we've said elevation a lot, and I think that's because we're a biased sample of snow leopard ecologists, so we often look at elevation, but what can you turn elevation data into? What you initially have elevation as a raster, and you can use some tools in QGIS to turn it into. Yes, Mustafa has already answered slope and aspect. Very nice. So it's not, elevation might be the original data set, but you can also look at ruggedness, which is really important for snow leopard, looking at what areas they're using in analysis. Very nice. Okay, we also have results of occupancy analysis, vegetation density. NDVI, yes, if you want to look at the effect of climate change on grasslands or the productivity of the grassland in the area, or you might use NDVI. Precipitation, super. So everyone, you guys are starting to get an idea that you can really do, it's a lot of different information. EVI, super. So now we're going to move on. And I just wanted to highlight again, related to different attributes that you might have with each location. So just for those that are unfamiliar, if your camera trap is located here, you would have the point, the GIS point of that camera trap. But then you could also have the elevation data information of that camera trap, where that camera trap was set up, in a valley, in a saddle. If there was a sign located when you collected that camera trap, whether you know this was an old camera trap, an old or new camera trap, the time, the date, for example, you can provide all that information in that one point. And that's really the powerful thing that lies in this data associated with that object. So just like a spreadsheet, data is organized for the shapefile in rows and columns. And an attribute table can have thousands of rows and columns. And there's no real limit. You can keep adding information to that point. And for example, this attribute table contains various fields in it, and each of them are different columns. So I just wanted to highlight that again. So this is how the data is for each shapefile. Now back to you guys, a few questions before we move. What's the advantages? Because there's some disadvantages and advantages of using vector and raster data. What is one of the big advantages of vector data? And I've written up here, but you can think of different ones as well. Yes, this was Chicham Village. Nicely spotted. I saw in the chat, someone said. So what are the advantages of vector data versus raster data? Because it's important to think about before you try to map that kind of data. This on my screen, it's quite easy. I think everyone here seems to be quite familiar. The advantage of vector data is you're really working with discrete data types, such as camera trap, transects, country boundaries. But what are other advantages? What's important to think about when you're using a raster? The resolution, right? Vector data does not depend on resolution. Yeah, you can change the resolution, but exactly. So vector data can be much better representations of reality because it can be much more accurate and precise data points on where it is. Think about when you take a GPS point, you're in the actual location, you're taking that GPS point, the X and Y of that GPS point can collect that data at very high precision levels with your decimal points going on for a while. That's very, very precise. And that's very powerful in a vector data, able to collect that. While the raster data will really depend on that grid size. And of course, you can collect very precise grid size, but then there's that compromise of then the data being very slow and chunky. Yeah, someone else has, yes, exactly. Braz has said vectors are precise, almost exact, exactly. Someone is saying, vectors do not depend on resolution? Not necessarily. It really depends on the resolution of that data point. They're easy to work with, clipping and getting attributes of the other vector compared to rasters. Yes, that's true. It's much faster to process the different analysis typically. And they tend to be also very authentically pleasing, right? You can create some beautiful designs with them, changing the design of it. Of course, you can do this with rasters, but you might be a little bit more limited. You might not actually be able to add labels in rasters compared to vectors. And it's really nice sometimes to add different labels of, for example, what elevation was this? What was the name of the village? And that can be done with a vector. The vector also has an increased ability to alter the scale of observation and analysis. Yeah. But then what about rasters? When is it really useful to be working with rasters? Super. Okay. Someone is saying that raster data can be used as a base map. And so we can extract information on vector data from the same raster file. Super. So that raster data can really provide information for the vector data, such as elevation, slope, or maybe a satellite photo where you want to extract some information. Raster information might also be very good for large area analysis, right? Because you're able to really get detailed data easily across that large landscape relative to a vector where you need to create that Excel file with each data set having that specific information. And that might take a long time to prepare unless you extract it from a raster, as someone just mentioned. And rasters might be better for mathematical modeling. Again, because you might want to have a larger sample size for your analysis because it has more spatial detail. So those are just some things to think about when you're doing your work. Okay, let's some more questions now. Just for those that are less familiar with QGIS, when you look at this file, this is actually a DEM, which has been, which we've changed the colors for high elevation as red and low elevation as blue. It's a GeoTIFF. What is this? Is it a raster or is it a vector? I just want to make sure everyone's very familiar with this because it really affects later your GIS familiarity. It's a raster. Great, Joshua, Saddam, everyone's saying it's a raster. And what about this? Elevation contour lines. Vector. Super. So this has extracted information from a raster to create this vector, which is more of a lines. What about this? It's represent different snow leopard home ranges in a certain area. Vectors. Someone said raster. Well, it's actually a vector. It's just showing the general area for that snow leopard. Okay, so before we go on, I wanted to check in first with everyone to see if there are any questions related to these basic concepts. If there are no questions, then we will proceed. And then we're going to proceed with just a little bit more of a talk, and then we're going to go into the workshop itself in QGIS. Okay, so now let's move into QGIS. Why did I choose QGIS today? Because one thing that I've really loved over the years is that it's open source and it's free. And it really supports viewing, editing, and really playing around with data. But generally, what I find most useful is it's accessible to teams in the field as well. You might be working with rangers or different protected area staff, for example, and they also can benefit from learning from QGIS and building these skills. And if QGIS, since it's free, they can download it and also use it, and you can share data accordingly or share tools. So that's one of the biggest why I'm such a fan of this approach. It's also applicable on different types of computers, for example, Mac, Microsoft and so on, which makes it very user-friendly. But of course, there are many different alternatives, for example, ArcGIS and other powerful tools out there. So don't limit yourself by just using QGIS, but perhaps when you start using ArcGIS, remember that it's not fully available to everyone in the world compared to QGIS, which is free and open source. Yes, so I just explained this, and you can work really with teams that have limited funding in the field. So back now, I'm just going to share back to how we can add vector files related to formats. When you go to and you add a layer in QGIS, you add a vector layer. One thing we forget about is that vector layers are made up of many different files. And this is just an example of a protected area of Mongolia. You can see that it's not only the shape file, the SHP file, it also has data in all these other files that are explained here, which represent the geometry, the projection information, and so on. So when you store your shapefile data, it's important to store all of the different attributes. Yeah, because otherwise the file won't work properly when you add it to your GIS. Similar for raster files, as I said before, you can see it as a picture, like a snow leopard picture, but the difference is that each of these grid cells have a geometric, has a geoposition related to it. And this is normally in a little Word file related to that picture. So raster formats, they can be different images, digital cameras, video recording, satellites, and so forth. And what's the difference is that they have this geolocation for each location. So I sent an email yesterday asking everyone to maybe watch the tutorial or look into geographic coordinate systems because we don't really have time to look at this today, but I just wanted to go over it just to make sure we're all on the same page before we move ahead. Because this is very key to, and you might be able to address any errors you face as you do your work. Because we're mapping something. And when we map something, we have to remember that the Earth is round. The Earth is not flat. And that means that when we're trying to locate an area, it impacts the accuracy of how we locate that area. And generally, every place on Earth is specified by 2 or 3 numbers, but generally we use 2 called coordinates. And these are the latitude and longitude coordinates. And this is the general principles of a geographic coordinate system. And it's a reference system identifying the location on the curved surface of the Earth. And this is based on angular units that you probably saw in the tutorial, or you can look later, from the center of the Earth. And you can measure then the 2 planes, and which is defined from the equator. So lines of latitude are the north and south of the equator. Yeah, and then they are really, they divide the Earth into 180 equally spaced sections from north to south. While and latitudes north of the equator tend to be positive, and latitudes south of the equator tend to be negative. Okay, so if you think of latitude, think of the equator and moving north or moving south. And then there's the longitude lines, and these run perpendicular to the equator. Yeah, and they really go from the south and the North Pole. And the 0 line that we use is the meridian, and it's the 0, the Greenwich meridian that you may be familiar with, and then you go plus and minus from this, or you go east and west from this. So therefore, all of the different locations on the Earth, around Earth, is defined by a geographic coordinate system based on this latitude and longitude value. So what does that mean when we write this data by hand or on our GPS? It means that we normally write them in degrees, because degrees are, and degrees, minutes, and seconds. Degrees are divided into minutes and seconds, with every 60 minutes being a degree and every 60 seconds being a minute. And there are different ways you can write your data. You could write it as a degrees, minutes, seconds data set, for example, and it's normally represented as DMS, where it's 100 degrees, 15 minutes, 36 seconds east. Yeah, and you've often probably seen data represented like this. Another way is the decimal degrees, 100.26 or 48.18. And this is another way to represent exactly the same thing as here, but it's more as a decimal. And you can also have it as degrees, decimal, minutes. And this is just a little bit less precise, but you can use it with the decimal place as well. So it's exactly the same as the first one. So now I have a question for everyone here. When you're collecting your data in the field, or you're asking your teams to collect data, whether it's community members or rangers, which type of data format do you generally use? It would be interesting to hear from everyone what they generally use. Okay, Sarjanit says DMS, degrees, minutes, seconds. Joshua says decimal degrees. If you have shared, can you start thinking why you chose this method? Why are you choosing this versus the other method? Okay, I see a lot of others saying decimal degrees, degrees, minute. Decimal degrees, DMS, DMS, DMS. Okay, Flavia, DMS. Can you explain why you use DMS versus DD or DM? Or the others that are using DD, why are you using this instead of DMS? It's just important to think about, again, the pros and cons, because it can have a dramatic effect on your data and different errors you can have in the data set. So as Saddam is saying, easy to note manually. Can you explain which one is easy to note manually? Get more accurate data. Okay, so Riyaz is saying DD is easy to write and type. Yes, easy to communicate. So for all of those, I use DD to avoid conversion errors and retain accuracy. Nice. So I am on the similar thought as many of you sharing in the chat, because there's many errors. As you put it in Excel and someone else then tries to read the data and so on, they might think you're representing it as DMS instead of DD, and they might think you're using DM instead of DMS, and it can get very, very confusing quickly. And then you convert it, and then the data is wrong, and there's an error in your data set just because you misinterpreted how the data was given to you. So generally, what we do is we use decimal degrees. This also creates less confusion with whoever is collecting the data, whether it's rangers, whether it's community members. There's less parts to the data, which can create confusion on the GPS to noting with compared to the DD. But one thing that's really important is to make sure that it's well annotated, whatever data you're collecting with your team, so that the next team member that's using the data has a clear idea. Otherwise, it can go really wrong and we can have a lot of conversion areas, as Kamalika just shared. Okay, so that's just something to think about. For those using DMS, I just would ask you to just think about it. What could be the advantages of using DD, because it might avoid transcribing errors in the future. Okay, so that was if we were mapping on the world, thinking of the world as a symmetrical globe, which it is. And generally different in GIS, we could use, this would be a geographic coordinate system. WGS 84. This is often how we project or look at maps in GIS. But when we create maps, they aren't round, they are flat. And we need to create this 3D surface and put it into a 2D surface. And this has been a question geographers have been trying to do forever. How do we bring this round object into a flat surface? And we do this through map projections that try to portray the surface of the Earth, or perhaps just a portion of the Earth, on a flat area or a computer screen. So how do we bring this 3D into 2D shape? So the decision on how to do that really depends on where you're working, what you're analyzing, how accurate you want to be, and the availability of your different data. Because depending on that, every time you try to flatten a 3D into 2D, you'll distort distances, you'll distort areas, and so on, which will have a bigger effect on your map itself. And map projections are never absolutely accurate representation of the spherical Earth, but because they distort these angular conformalities, distance, area, but they do try to do the best job they can for that specific area if you choose the right projection. And there are many different projections that you can choose, depending if you're using a global map, regional map, or maybe local maps. And and it really has evolved also with time as we get a better understanding of the shape of the Earth, because the Earth isn't really exactly spherical. It's a bit like a squashed, I think they say a squash orange or of some sort, and it's perfect. It's not perfectly flat as well. It's a bit curved. So they're getting more and more detailed understanding of that to be able to get more accurate maps. So one map projection that tends to be used to calculate areas that's very good at the local level or regional level is UTM projection. And it's the acronym for Universal Transverse Mercator. And it's a coordinate grid system that is named based on a transverse Mercator projection. So I'm not going to go into that today because I think there are a lot of tutorials about that, and we want to go ahead straight to the workshop. But just this is something to think about because it will influence how accurate your area is when you do a calculation for how big your protected area is. It will also create a lot of errors when you do analysis because you think your two layers are overlapped, but actually they're not. They're projected differently because each layer is projected with a different coordinate system, and they need to be on the same coordinate system to do an appropriate analysis. Yeah, so that's just something to think about as you go ahead and explore GIS. And this is a really nice way to look at it. This is a nice map that shows that we all are probably used to looking at very skewed maps. Yeah, and this is if you actually bring some countries onto different parts of the world, you'll see that they actually look bigger or smaller than you're used to looking at them on these flat skewed maps. And you can play around with this. There's a website called The True Size, which helps look at how our views of the Earth are distorted by these types of maps these flat maps that we view the size of countries when they might not actually be depicting the actual size or comparative size of different countries. So I see a question from Sanjit. I ask rangers to collect locations in DMS. Although I personally do DD, they often confuse the two systems and write DMS digits in DD format or vice versa. Hence, I ask them to record in DMS. Yeah, that's fine, Sanjnik. Yeah, whatever works for you, but as long as you're clear understanding what they're using and they're clear what understanding they're using. If they're used to using DMS, that might work better for them and for you. So look at this website I just shared to get an idea of these kind of distortions. And then we're going to move to our tutorial. So it's already been an hour. So before we move to the tutorial, I want to get another question from you guys from our Mentimeter. So I'm going to share my screen again. A very important question. share, where do you generally get your GIS data from? Whether it's vector or raster data. Can you be specific and say which websites you found very useful, which type of data, and share with everyone? Because it's important to look at this and have different data available, because we don't need to only depend on the data we collect in the field. There's a lot available. Super, USGS for world climatic data. So for those writing acronyms, please spell it out. I'm not so familiar with all of the data available online, so please do spell it out so we can understand each other. USGS Earth Explorer, DIVA GIS. Chelsea World Clim, okay. Globe Cover, World Clim. Did you know that for snow leopard data, there's also the IUCN, mammal distribution maps. Of course, with the snow leopard distribution, it's a bit outdated, but that's also available. There's also the GSLEP GIS repository that has some key data that we'll use also today. There can also be base layers for your maps. And these base layers might come from Google Maps, for example, or from Bing, that can help see more detailed resolutions of where you're working through online links. Yes, Google Earth. USGS Earth Explorer. Yes, there's also Earth Explorer for rasters. Nice. Okay, so there are a lot of different resources. It's important, of course, to explore them, and for rasters to look at the different resolutions that might be available, because different rasters might come in different resolutions. So now let's move on to mapping, which everyone is here to do. So if you have QGIS, please go ahead and open it. It might look like this. We're going to go through ArcGIS now and do a little bit of a tutorial. I know it might not be everything everyone wants to do, but it hopefully will give you a taste of how you can use and create different useful maps. So first, we're going to start at the regional level. And this is the new QGIS. If you haven't updated your QGIS, I think it's important to look. You can look at About QGIS and just check what version you have, because they keep updating it, and it's important to keep it updated to the latest version. So you can just check. This I re-downloaded recently, which is 3.3, it has the latest tools. It's available for Mac or Microsoft or Linux, so you can use it on your computer. Okay, we're going to start off by first exploring base layers, like I just mentioned. Everyone mentioned different raster or vector sources. There are also base layers that use, for example, our Google Maps to help us explore data and visualize it. So there's this tool called XYZ tiles that make it now really easy to find these base layers. So you can create a new connection. It's basically, you have to be online to do this, and you create a connection. You might call it Google Earth, and then you put the Google Earth URL related to the XYZ tile. So this is also available online, and there are many different options for these kind of data. And you can create a range of these, even using OpenStreetMaps. So I'll show these just so you can have a look. If you're looking at Google Maps, all I have to do is drag it onto my screen, and there is my Google Maps. I can take my zoom function here and go towards High Asia, which is our area of interest. And you can look, it's just like your Google Maps, it's in very detail. If I wanted to go really close into my study area in the South Gobi Mongolia, I could, and there I am. I'm in Gervantes and Tost, and these are my Tost mountains. Yeah, if I wanted to go back, all I had to do is click here, which is the back zoom to the previous zoom. I click it and I'm back to the High Asia visual. But there's not only Google Maps, there are a number of different ones, because the issue with Google Maps is it might show borders, right? And borders can be very sensitive. They can be contested in many areas, which it makes it hard for us working across the Snow Leopard range to use. So there might be other maps that are less specific related to the borders, like World Hillshade, that you can use, which is really nice for us that are working with a mountain species to show the ruggedness of the different habitat across High Asia. There are also OpenStreet maps, which are similar to Google Maps that you could use, and so on. So you can explore with these different maps. They're really helpful as a base layer. Yeah, and here, as you can use your layers tab here to decide which layers are visible by clicking the yes or no option. So I'm going to keep my World Hillshade and I'm going to move it to the top so that it's always visible. It's the top layer of my project, and I'm going to keep it there. Now I am interested in the Snow Leopard range, as we explained, and this can be downloaded from IUCN, or it can be downloaded from the GSLEP GIS repository. So I'm just going to go to my first workshop and find that shapefile. So here I'm going to go to GIS layer, add layer. I can add a vector layer through the Finder file. I click it here. And then all I'm here is I'm in this big box, and I can add whatever layers I've already downloaded from online or created. And I'm going to define where is my source for my layer, and it's a vector data set. And I'm going to click it, and I've saved it as our first workshop. And I'm going to show the Snow Leopard mountain ranges. And as you can see, all the different parts of the shapefile don't come up, that you don't see a nice figure. The best thing is to click the shapefile, because this brings all the different data sets together onto your GIS. So I click the shapefile, I press open, and then oops. So let me try again.
Justine, sorry, I think some people aren't getting the option of Google Maps.
Is there a question in the chat?
Yes, I mean, they just mentioned that they're not getting the Google Map option.
Yes, so one moment. You can actually go to, it's, you have to go online and find the appropriate URL related to Google Maps. You can't just put in Google Maps from online there. So that really, you have to look online, and I'm going to just look up the different resources to help you get that. For example, here, I have it here. Try these different links. These would be the different links for the different Google Maps, satellite maps, the different Google Maps that you put into the X, Y, Z tile figure. Yeah, so you have to, it's not just Google Maps, there's a specific URL for whatever data you're adding as a base map. Okay, so as you can see, I've added my mountain range, my shapefile of the Snow Leopard distribution mountain range. However, I can't see it on my map. And that's because it's underneath my, my base layer. So I have to move it up first so it's above my base layer. So I'm going to move it, and there it goes. So this is basically the Snow Leopard distribution, also predicted by IUCN. And for now, it really just represents the general distribution of where snow leopards are. right? But I want to make it a little bit more informative. So what do I do? Well, remember, it's a shapefile, and a shapefile have many different attributes related to it. So I can side click and open attributes table that is related to that file. So I'm going to open my attributes table, and related to on each different file, we'll have a different attributes file. And if I open it in this case, you can see that it has different data related to it, even the area in kilometers, the expert person name who collected that specific amount of data, the country, and then the snow leopard probability, whether it was definitive or probable, the type of habitat, and there's a huge number of attributes related to threats when it was originally collected. And finally, if I go all the way till the end, it has the type of range, which is also listed. Yeah. So first, if I want to depict the snow leopard range differently, I can side click and go to properties. Do you see my properties tab, my symbology tab? Just making sure. Raki, do you see this? Layer properties?
Yes, I do.
Yeah.
But first, Muzaffar is saying some window is not visible. Not the attribute.
Was the attribute layer not visible?
It was to me. I don't know if he's talking about his app.
Okay. Okay, maybe. So on the GIS, on GSLEP website, you'll get the same attribute data for your data. It depends where you get your data from. I don't know if IUCN data has the same attributes. So then you go to that data properties, and then you can go to symbology here. And right now, as you can see, it's depicted as a single symbol. So you can go to categorize. And perhaps I wanted to look at the IUCN different categories, which was related to snow leopard probability. I can click that, and then I can classify to see the different areas. And I open it, and it's got definitive, possible, probable. I can delete this because this is all other values. And I can decide the colors, but for now that looks good to me. It's some random colors. And all I have to do is apply. And I press OK. And now my map is depicted as these different areas. And here is the key to get an idea of what I'm depicting, right? So the orange are definite, blue is possible, and the pink is probable. And you get a better idea of where it is. But what if I want to look at the snow leopard ranges, the mountain ranges, because pretend that's my goal? Well, I can go back to properties, and I can go to the final attribute, which was range, and I have to classify again. I say, yes, I want to delete the previous classifications, and here are my different mountain ranges. I press apply, which is nice. And now it's depicted along the different mountain ranges. And as you can see, there's these awful, not nice looking lines representing the different areas. I can go back to properties and get rid of that by clicking symbology and choosing simple fill and getting rid of the line and putting no line. So here you can play around with this further, fill or simple fill, to decide how you want to play around with that color. Perhaps I also want to make it a little bit see-through, so I can see the ruggedness underneath the map. I can look at opacity and decrease. Yeah, so there are many different ways you can play around here with this symbol setting. I press OK. Now they're a little bit see-through, all of the different mountain ranges. I apply and OK. So there we are, the different mountain ranges across the snow leopard range. So after we've shown the snow leopard distribution according to different mountain ranges, you might only be interested in China, for example, because perhaps I'm only working in China or Mongolia. and I'm only interested in that area. Well, I don't have to create a different shapefile in my area. I can still keep the same shapefile, side click, and filter my data. Yeah, and what can I filter based on? Like we discussed, the layer has many attributes, so I can filter according to those attributes that exist. Yes, so I can click filter, and here my choices for filtering are all the different attribute columns that are associated with that data. So if I'm interested in country, I can click country and double click. It comes into my calculator, my expression, and I want pretend China, but I'm not sure how China was written in the actual data set. So I can still click country, and then I can look at all to see the different values. And you'll see that all the different countries associated with that attribute in the attribute table are listed here. And then I can click China, and I can double click it to add it. But remember, it's an expression, so I can't just write country China. I would have to say country equals China to filter and just have China. And then I press OK. I press OK, and now I only have the mountain ranges for China. So this is just a quick way for you to filter through the different data set that you might have without creating a number of different layers, because that's what someone, if you're not familiar with QGIS, you might just create a number of different layers while you can just filter here. And I'm going to do it again, except for this time I want to do it for Mongolia. So instead of country equals China, I'm going to change this to Mongolia. And I'm going to press OK. And now the mountain ranges for Mongolia are displayed here. Yeah. So this is a first step of how you can play around with the different visuals of a vector file. Okay, so I'm just going to look at the questions. Yeah, thank you, Flavia, for putting the resource for that GIS data. The data on the distribution is also available on IUCN, but it won't have the mountain ranges. The mountain ranges are on the GSLEP resource. Okay, so from there, imagine now I'm working actually at the Mongolia level. So that's why I've filtered for Mongolia. This is the Snow Leopard range from Mongolia related to the different mountain ranges. We see the Altai and we see the Tian Shan. So I'm going to bring on the data set here, I'm going to bring Mongolia's protected areas. So I have another shapefile that I've downloaded from online related to Mongolia's shapefiles, protected areas. And I'm going to, another way to add shapefiles is you can just drag your shapefile onto the window and it adds it. You don't need to go above nowadays. You can just drag your raster file onto that window and it can add it. So here I've added my Mongolia protected area shapefile. Again, it's important to look at what attributes are associated with the shapefile. So I can right click and then go to Open Attributes Table. And I can see what data is related to it. Because it's from Mongolia, all the data is written in Mongolian, but I can maybe ask someone to kind of get an idea of, for example, what is this data showing? I know, for example, that number 1 means a strictly protected area. Number 2 is a national park. Number 3 is a nature reserve, and so on. So I can understand this data a bit further. And then this is the area that's already been calculated for the different protected areas in Mongolia. So I'm going to click that data set, and maybe I want to also play around with the symbols of this data set. I go to Properties. I go to Symbology again, and I can again categorize. But this time I want to categorize by the type of PA. because Mongolia has several types of PA. So I can SPA type, and then I press classify, and it will list the different numbers. But I won't remember what 1, 2, 3, 4 is. And sometimes your data is like this. You can write in by hand. Okay, number 1 means strictly protected area. Number 2 is national park. And this will help when you create a map later. Number 3 is nature reserve. And number 4 is natural monument. So that I remember. And then I can press OK. And it has my protected areas over Mongolia overlaid underneath my snow leopard range. So I might want to move it so that it's above the snow leopard range. So I move it on the side, so then it's above it. And I can see both of them together. Pretend, we looked at the protected area shapefile for Mongolia, and it already had the different areas of each protected area. I can look at this by clicking on protected area, and I have a summary statistics option up here. And it says show summary statistics. So I can click on that, and a new tab comes here on the left. Yeah, and I can say, okay, for the layer of protected areas in Mongolia, can you create some statistics, a summary? But I have to again decide which attribute do I want the statistics for, and I can click it and say I want it for the area. And it will provide me as just a general summary, the mean area size of all the protected areas in Mongolia, the median, standard deviation, range, and so on, which can be very useful. However, if I want the same statistics for pretend just strictly protected areas, I can do the same thing we just did previously with the mountain ranges. I can click, and I can go to filter, and I can define its SPA type. I don't really know what it's using, and can go all. And I remember that the 1 meant strictly protected area. Can go equals 1 and press yes. And now it's only the strictly protected areas showing in Mongolia. And accordingly, I can go back to my statistics and look at how this has changed. I might have to click it again so it updates. So now you can see it's re-updated the area only on the strictly protected area data set that I've filtered for. So I'm just showing you this to give you an idea of how to explore your data using different filters, but also making it really nice and pretty to when you create a map. Yeah. So let's go back to our map and imagine that we wanted to go back to the Snow Leopard range. So we're going to remove that filter. We're going to delete, and we're going back to the Snow Leopard range. And I want to zoom just that Snow Leopard range. I can side click, and I can just say zoom to layer, and it will just zoom to my Snow Leopard layer. Yeah, and imagine I'm creating a map of the Snow Leopard range. So we're going to do a little tutorial on creating this map. But before I do that, I wanted us to go over together, what do we need to create a map? I see someone's already written legend. Okay, that will be really important. For my map that I'm trying to create related to the Snow Leopard range, what legend would I have to include? Scale, yes, otherwise we have no idea of what scale we're talking about. Base layer, to give an idea of the topography of the area. North arrow, important. Lat long grid lines. Legend. North sign. Home range shape files. presence point. Okay, yeah, and just, I think geographical coordinates. What about when you see maps, do you normally see an inserted map, other map, that shows where your map is? That will also be important and is generally required because, yes, an inset map. Otherwise, your audience will have no idea where your study area is. So they need to have a better idea, maybe with a picture of Asia or elsewhere to give it a good idea. Related layers. Title. Yeah, also a title is important. Super. Okay. So I'm going to stop my share. Seems everyone is familiar with this. And you might also want to put the date of where you're working because you're just to keep a note of the date. And you might also want to put a copyright, for example, on any organization or any of the data comes from any different organizations. You might want to add that as well. So back to our map. If we are to create a map with this, we can go easily to New Print Layout here in QGIS. And we might want to call it Sample Snow Leopard Range. And we say, okay. Does everyone see my United Project QGIS map layer? Raki, do you see it?
Yes.
Yeah, the blank sheet?
No.
No. Okay. Then I will reshare. Super. This, do you see it now? Yeah. Okay. So this is your tool to help create a map. And to do that, you have to now add the different items on the map. So we're going to add our map first to the sheet. And I can just create a thing and add my map. It's rendering. And it's then put the map onto my canvas. Imagine this is your canvas that you're going to then export as a map of your area. So one nice tool that makes it easier to work with, if you go to the Edit tab, you can move content within the map. Pretend the map is completely in the wrong place and it's presented like this. You might want to move the content so it's really in the middle of your map, so you can really move it all the way to the left side. But you have to really make sure you've clicked Move Content instead of the Select Move Item, because that will move the items within the map. Here, if I try to now move the content, it's actually moving my whole map. It's not moving the inside content. Yeah, so that's just one thing to think about. Then like we just said, we might want an incent. So for this map, I can lock, and I want to keep the different themes, lock layer, lock styles of my layer for this layer, so that I can play around with my other GIS window and it won't change the image I see here on my canvas. So I'm going to go back to my GIS folder and I want to create an inset map. So I'm going to maybe zoom out, but then again, this background layer now isn't very nice for that inset layer. And perhaps I don't actually need the Snow Leopard mountain ranges for that inset layer. So I'm going to unclick the mountain ranges. And I'm going to look, and I actually have this already ready, is a land map for Asia, which is also a shapefile that nicely depicts Asia. So I've added this shapefile, which is from Natural Earth, showing Asia, the continent. And this nicely is maybe a simpler inset map that I can put next to my other map. However, it's already in a bit of an ugly color, so I can go to properties and change it slightly to make it perhaps black. I apply, and there I have a nice inset map. So now I go back to my previous canvas. I still see my old map here, which is good, but I have to add a new map, and I can put it at the side and add my map, which is really nice, but I still have to deal with the issue of where am I talking about in this area? So that there's actually a really nice tool within QGIS that helps with that. So I can make sure I'm still clicking on my map number 2. And I can go down. There are different tools I can play around with. And I can go to overview. And wait, first I might want to frame it because it wasn't framed. So I'll frame it. I'll click overview. And I can add an overview. And I can define that I want to add the map 1 as my overview. And you see what's happened here? It's added a box directly where this map is located, which is very useful because it's a very accurate overview of your other map. So you can decide the features, what color you want to be for this. Perhaps I don't want it to be pink. I'm going to make it white. I'm going to go back. I want it to be white. Yes, and I can create a white map, for example. Maybe white doesn't work so well. Maybe I don't want any brush at all, but I want a line. So I add a solid line around and I make it a little bit bigger, the stroke width of the line. Perhaps this is not big enough. I make it even a bit bigger. And there we go. I've created a nice box for where I want to show my snow leopard mountain range. But there's still more that I need to add, as we just discussed, is, for example, the legend. So I go add item, and I can add a legend. I click where I want it, perhaps here, okay. And it's added all of the different information from the different data I have on my original map. And I might not want everything, so I have to go to the item properties here and unclick auto update to remove. For example, the protected areas in Mongolia, I'm not interested anymore. So I can delete this. I'm not interested in this inset map file, so I can delete it. All I'm interested is in this, and I can see the different layers, but I can also remove the basement layers because they're not so informative. And then I can call it, make sure it's named properly. Could be Snow Leopard mountain ranges within the Snow Leopard predicted distribution. IUC, something like that. I could put mountain ranges with the Snow Leopard distribution. It's already pretty long and ugly, so I might want to shorten it. And I might want to put it here instead. If I put it there, though, I do want I want it to be see-through. So I might go down and make sure. Legend. Oh, I think it's, I have to go back. And then I can check and say, I don't want the background, if this is the case. But then my map again doesn't fit onto my canvas, which is very unfortunate, and it's overlapping too much. So I can go back to what I shared earlier and go to edit, move item, and I can move, make sure I'm on the proper item. I'm on map 1, and I can try to move my item, if it will move. Move content. because I've locked it. Oops, there, I unlocked it and then I move it slightly to the right and this works much better, yeah? But we still need to add a scale, so I can add another item and I can add a scale bar. It's easily here and just press OK, and it just creates a scale here. And then I can play around with this scale properties. You have to really make sure it's linked to the map 1 and not linked to map 2. You can play around for how you want to display it. I like to put it with ticks in the middle. And you have to really make sure the units are correct. So you want to go back to your map and really ensure it's depicted correctly. And how many to the right, how many to the left, and so on. And then you can add your scale. Another thing that everyone mentioned was the north arrow. So you can add a north arrow. And maybe I want it just here. And it will just create a north arrow. Okay, so we've created a beautiful map of the snow leopard distribution according to mountain ranges, really quickly based on the data available. So I'm going to now move on to our second workshop. But if there are any questions, please let me know. Any questions so far? I know it's quite fast, but we didn't have time for everyone to be working on their QGIS at the same time, but I hope you can look at the recordings if you want to look at the details. It was just to give you a taste of what we can do.
You had a question from Sagnik, Justine, asking, can you tell how probable is different from possible categories?
Okay, so good question, Sagnik. I think we have to go back to the IUCN definitions to look at that in more detail. Yeah, I'm not, someone else here might have the definitions handy, but it was based on the assessment on snow leopard assessment on whether presence was there or not. And everything's explained on the IUCN website. Okay, let's work on our next workshop, which will be about contours. And I'm going to show a camera trap study area. Okay, we have, but first I see another question has come in from Braz. How advanced is the requirement of GIS proficiency when working with QGIS in the field for snow leopard-based activities? So I think it very much depends what you're working on, Braz, and some people just get away with just using their GIS and recording their GIS by hand, and then just mapping those GIS tools onto QGIS. But the more familiar with it you are, the more you can do, and you can then assess your work and improve your work. So I encourage you to be proficient in just in terms of mapping and assessing and planning your work. You don't necessarily need to be proficient in data analysis using QGIS to plan your work. So I'm going to now, like Braz is mentioning, when we plan our snow leopard work, what can we do? So I'm going to go back to a new QGIS screen, and we're going to work with some camera trap data and plan our next field season based on our previous field capture rate. So I'm going to open a new project and share with you the project. So I'm starting from nothing again. Yeah. If I wanted to give myself a little bit, again, some idea of where I'm going, I can put the Google map in there to give it, or perhaps I want more Google terrain. So I'm going to put a Google terrain map in there. Oh, my Google terrain doesn't work.
Justine, Rutuja has elaborated her acronym.
Super. I'm going to use this space map this time to look in more detail at my study area. So if I was going to my study site and I had my team, my set of rangers collect the GPS locations of their different, where the camera traps are located, and they've written it in an Excel sheet. So I'm going to open that Excel sheet for you so you can have a look of how we've prepared the data. I'm going to share the screen from Excel. So this is my data sheet, my data from the different camera traps that were set out in the field. So this is my different camera trap numbers, the ID. You can see that you need to organize your data in the same way the attributes table in GIS is organized. And your first row is the labels, and then you have the data for each data point. And I have the lat long for each camera trap. I also have the elevation, and the team has written down different attributes for each camera trap. For example, it was set up at a saddle. There were any signs there? No, or maybe there were scrapes. It was new or old signs that were there, the time and date of setup. And also we have the number of captures of snow leopards. So in each different snow leopard independent capture event for that camera trap that was later put in by our team to assess if we should go back there and set up new camera traps. So all this data is in just a regular Excel sheet and inputted by our team. And as you can see here, we're using the DD format because in our case, it helps reduce errors for later transcribing between handwritten and Excel when we put it into our computer. So one key thing is we can't input this data using Excel into QGIS. We have to save it into a text or CSV file. So when you save your file, you can go Excel Save As, and you can click what version you want it. You don't want Excel workpoint. You can go CSV, perhaps data limited. So you have to check out your computer and how it saves the different CSV files, because Macs and Microsoft computers might use a dot instead to delineate the differences, or they might use a column. So it's really important to be very specific. In this case, it's comma delimited. So I'm going to save that and then save. I've already done so. And then from there, I can go back to my GIS and I can input these camera trap data. But how do I do that? It's not a shapefile. It's not a raster file. All it was camera trap locations. Well, luckily I can go to layer, add layer, and it's called data add delimited text layer, which is exactly what I've saved my file as a CSV. So I can click that, and it will convert my CSV data into a shapefile, which then I can continuously use as a shapefile with different attributes related to it. So I have to find my Excel or CSV file from my computer. I'll go to wherever I've stored it. It was called camera traps. So you go, and that's when I went to layer, add layer, it was add delimited text layer. This was what came up. So I've said where the file is located, and it automatically adds the name. I can also define what kind of encoding, maybe different computers, or you've saved your file differently, maybe it's a text file, a CSV, and so on. You can then define that. And then it's already looked at the data. If I look down, and it's already just looked at what my different attributes are: number, camera ID, long, lat, elevation. So I have to add that geographic reference data to this so it recognizes where to plot it. So these are the point coordinates, and that's the X and the Y field. So the X, as you remember, is the longitude data. So I'll go to long, which matches the longitude data. And the Y is the latitude, which we looked at earlier. So I can click that. And then I have to decide my geographic CRS, which was how we project the map as a flat canvas, because remember, the world is round. And in this case, I was using my GPS, looking at and pretending that the world was round, using WGS 84, which is a geographical reference system for when it's round. So I'm going to keep using that so that I don't create any errors in my data and use that format. In other cases, if you're using DMS coordinates, you can, of course, click here and format accordingly. So I add this file to my QGIS. I just press add, and I'm going to stop sharing to share back to my screen. And you can see here, my camera trap locations have been added to the site. So I can again side click this shapefile. It's now become a shapefile on my layers tab, and I can zoom to layer. So I'm going to side click and zoom to layer. And now you can see all of my camera traps located in the area. This base layer seems to be less useful right now, so it's not very high resolution. So I'm going to remove it. And I'm going to try again to look at the hillshade file, because that tends to be higher resolution, and put that as my base layer by just dragging it. As you can see, it shows now the different mountain ranges in the specific area. So these are my individual camera traps, but right now it doesn't really give much information. I might want to look at what are the camera trap ID, which we haven't looked at yet. So I can side click properties and make sure you guys are seeing the properties tab. And I can, from here, decide, for example, and add a label. Perhaps I want to add the camera trap ID label to my camera traps. I can go to single label and add what label according to my attributes. And it can be just the camera trap ID. I have a lot of choices on how I want to format my words, but I can just press apply and press OK. And then now you go back to my map, and all of the different IDs for the camera traps are located here, which is very useful for planning your camera trap layout, and you want to see how far the camera traps are from each other. I could, for example, take this measure line and just get an idea, okay, how far are my camera traps from each other, and estimate this, looking and getting a rough estimate. Remember, because I'm projecting using the round spherical, so it's not projected completely accurately, but I can get a general idea of the distance between my different camera traps. Yeah. So from here, I want to plan next year's survey. So if I'm planning next year's survey and I know how often each camera captured a snow leopard and a separate capture rate, so not separate individuals, but different incidences of captures, I can go back and make sure this data is in the attributes table. So I side click, open attributes table. Okay, so you can see, so this is my attributes table related to that data set.
Right.
Okay, and then there's the different information related to it, the data ID, the long lat, And the last one, as you can see, is number of captures. It's exactly like that Excel file. And I have some cameras caught 0 snow leopards. Other cameras caught it on 16 different occasions. So I want to map that accordingly. So I'll go back to my original map. And I can side click properties again on the camera trap layer. Okay, so that properties goes up. I can go to symbology, click, and under symbology, I can go to a heat map. Create a heat map and decide what is my weight. And my weight for that heat map is my number of captures. What's nice about the heat map is I can decide the radius of how big an area I want to be warm, since it's the actual camera trap site, which I want to show as a key area and not necessarily the area around the camera trap site. I might want to make the radius smaller. So I might put it to 5. And then I apply that and I can go back to sharing my screen. And you can see now it's created a heat map of area of camera traps that caught a lot of snow leopards versus not. But it's still, I've lost now all the information from the behind base map because it's made it, this heat map has converted it to become more like a raster layer and into this grid format. So I'm going to go back and go to properties. And I'm going to go back to share with you my properties. Yes, layer properties. And I can decide the colors for this heat map. I might choose red. But actually, I want it to be transparent so that I can see the underlayer for that for the far area where there's no information. And where there's information, I might want it to be red. Oops. Let's create it. This color, I want to turn to red. And then I apply. And there you can see. Can you see my map again, Reki?
Yes, yeah.
Yeah. Okay, now I see my map and you see the base layer with the different heated areas where you expected to see snow leopards. Yeah, so this is helpful then for planning because camera traps that caught barely any snow leopards, I might want to reassess and put my camera traps a little bit further or where there are new signs instead of keeping those same areas. Or for example, these key areas, I would keep my camera traps in those key areas to make sure I keep capturing those snow leopards. But then I want to create a map so that my team can go out and plan this with the different elevation contours. So how do I do that? I want to create a contour map. Well, as we talked about previously, we could have a raster layer behind our data set that we could add. So I have extracted from online a DEM file, a raster file, and I can add it to my data set, but it's pretty ugly. It has each elevation at each different pixels, like that grid format we talked earlier. So I want from that data extract the contours. So I can do that by going to my toolbox and clicking contours. Clicking contours. Do you see my contour tab, Reki?
Yes.
Okay, this time it's showing up. And then deciding, and then just quickly deciding, okay, I want this raster file. So it's my elevation raster file. And I can tell it which intervals I want these contour lines. In my case, perhaps I want every 50 meters. Make sure you generally, this interval really will depend on what your raster is using as its integers. And you can see from mine, it's from 2,690 meters. to 857 meters, and that's the elevation of my study area. So I know that this, if I put 50, it will be 50 meters within this. So I can click yes, and then I just quickly say run. And it's going to take a few moments to process to create those contour lines. I put close, and now it's created the contours based on my raster. But again, this is quite messy. It shows I can only really know that closer together contours mean that it's maybe more rugged versus flatter areas. The contours are further apart from each other. So how do I add the contour labels, again, like we did with the camera traps, to the data set? Well, I might not want to add the labels all the time. I might want to add it only to every 200 meters of the contours. So I can decide that by going to my contours, opening the attributes table and seeing how the data is presented. So each line will have a different elevation. Yeah. And it shows the different elevations accordingly. So what's really nice about this attribute table is you can add attributes using the calculator button. It's called Open Field Calculator. So I can click it and add. Can you see my field calculator, Ricky? Contours field calculator.
Yes, yes.
Okay. So then I can create a new field to my attributes table. And perhaps I call it every 200 meters. I want to add whether it's present or not to make it bold. So then I call that field 200 meters, and then I have to put an expression to make sure it does that. And one expression that's very useful is the if. So here I take if, and then I look at my elevation contour, and I go, if elevation is at 200, every 200 meters, then it will equal, if it's equals, so this is like a dividing. So if I divide it by 200 and then equals 0, then I want it to write 1. Otherwise, if it doesn't fit, I want it to write null. So it's a general equation. I put it in there and I put yes. And as you can see, it's added a different column to my attributes table. And in the, you'll see that it says null when I said it should, when it's 50, but as soon as there's a 200 integer that's related to 200, there's a 1, yeah, which is very useful for my styling. So I can go back to my contours properties and categorize my contours according to this 200 meters and classify. And according to the 1, I can make this bold. Maybe a thicker line that's black. And the other lines I can leave as gray. I can apply. And therefore, it's created something that is slightly easier to read. Now I know that every 200 meters, these are the main contour lines. Yeah, it gives a better understanding of the area. But last thing, and this will be the last thing I'll show today because I'm mindful of time, we want to add labels to those contours, to these key contours. If I go to the attributes table, my labels, if I put this attribute as a label, it will show all the labels. So I only want labels to these 1 numbers. So I have to go back to my open field calculator, create a new field, and I can call it label. And I can say, okay, I want elevation times 200 meters. Because whenever this times this, if it's null, it will be nothing. If it's 1, I'll get that label. And I can press OK. And it will add a label column to my attributes table. Then I can exit and go back to properties. I can go to labels this time, not symbology, but labels. Single label. And I can decide where I want which attribute, and I'm going to call it label attribute. Press label. And I want it on the line instead of above the line. So I'm going to make sure on the line is taken and apply that. As you can see, it's very hard to read. Is it even there? Yes, they're there, but you can't even read them because there's no buffer. There's just the lines are there. So I'm going to go back to properties and add a buffer around the text so that we can read them. Now you will be able to see it. Maybe I want to change the text to make it a little bit bigger. I want to make it bold. Apply. Enter. And now you can see the different elevation layers for these just key elevations. Yeah, that might be helpful to do when you're planning and creating contour maps. Okay, we're already at 2 hours. I don't know where time went. And time has flown by, and I told Raki I was only doing an hour and a half. So for those that are still here, I mean, you can, of course, look at the recordings to look at the specifics. There's so much to look at using QGIS, but I hope this gave you a general idea of how to play around with visualizations and playing around with raster and vector files a little bit. There's a lot of for Snow Leopard data, there's a lot of different raster and vector files available that GSLEP is trying to collate. So if something does come up that you find very useful, please do send it our way so we can add it to the repository, because it's nice to have a central hub for a lot of these things. Basically, for QGIS, you should not be scared. There's a lot of resources online, a lot of tutorials, and you just have to go for it. Open the program if you can get it open. That's the first step, because it can sometimes be tricky. And then go for it. Okay. Thanks, everyone, for coming. I see a lot of thank yous in the chat. Thank you to you guys, and I hope you make the most of the next few sessions.
So much, Justine. That was really a learning experience. I think all of us learned a lot. So we look forward to seeing everyone next week.
Yeah.
Thank you.
Super. Bye-bye.